Hello, welcome again to another discussion this morning on this part of motion, and we are still on circular motion. Please don't forget we are still on circular motion, and we have a lot of things to really do under this motion, and it's one of the type of motion we discussed earlier. And don't forget, in this circular motion, we made mention of two forces: centripetal force and centrifugal force. We say one is inward force, the other one is outward force, and one keep the body along and the other one keep the body away. The one that keep the body along is known as centripetal force, and it's also called inward force, and while the one that keep the body away from the circular part is known as centrifugal force, and it's also called outward force. All right, now I want to now look at another discussion this morning on friction and centripetal force. But before I continue with this one, please don't forget, in my last class, I discussed tension and centripetal force. Tension and centripetal force. Please don't forget that I discussed tension and centripetal force. We said in the case of a rope, tension can provide the centripetal force if an object is moving in a circle or along a circular path. I repeat again, in the case of a rope, tension can provide the centripetal force if an object is moving in a circle or along a circular path. Remember, in my last teaching, or in my last class, or in my last discussion, we made mention of a rope. I said, assuming you have a rope and you tie a ball at one end of that rope and you weld it round, and what happened? The ball will maintain a circular path, and the force that will keep that ball on that path is known as centripetal force, and it's inward force. And the force that will provide that, the force that will provide it is known as tension, and that tension exists in that rope you hold in your hand as well. The tension exists in that rope you hold in your hand as you whirl the ball round. It means that tension provides centripetal force. Tension provides centripetal force in the case of a rope. Please take note, in the case of a rope, tension provides centripetal force. Okay, but now let us not divert our mind a little now into another discussion this morning, and this one is now friction. From what we have on board, friction and centripetal force. Friction and centripetal force. Let's say there is a car on the road, and if the car decides to turn on a curved path, what provides a centripetal force in order for the car to maintain this track as it turns? As it turns, assuming the car wants to turn on a curved path, what can provide this centripetal force as the car turns? It means that for the car to turn, it is friction that will provide the centripetal force. And remember, there are two types of friction. We have kinetic and static. But the kind of friction that will provide us, that will enable that car to turn safely without sliding, it is known as static friction. Please take note. The kind of friction or frictional force that will enable that car to turn safely without sliding, it is known as static friction. It is not kinetic friction. It means that static friction can provide centripetal force as the car turns. As the car turns, static friction can provide centripetal force. Please take note, as the car turns, in the case of a car or a car turning, static friction provides centripetal force. Now let's now look at a question on the board right away. Let us now solve this question on the board. And what do we have here? Okay, let us read. It says a car makes a circular turn of radius 20 meters. The coefficient of static friction between the tires and the road is 0.60. What is the maximum speed at which the car can safely make the turn without sliding? Remember, I told you earlier, I said for a car to make a turn safely without sliding, static friction will provide the centripetal force. Static friction will provide the centripetal force. Please don't forget, In my last discussion, we did something of this nature. Okay, let me take your mind back to Newton's second law. According to Newton's second law, sigma F, that is say the sum of the forces, that is say the force is equal ma. Please don't forget. According to second Newton law, force is equal ma. But for the one of centripetal force, it means that when you have your E, become the centripetal acceleration. Please don't forget, become the centripetal acceleration. Don't forget. Okay. Therefore, now the centripetal acceleration can be v squared all over r. Therefore, we can now conclude and say our Fc, which is centripetal force, is equal mv squared over r. This is the formula we use for centripetal force. Please take note. Remember, I told you for the case of the roof, tension provided. Therefore, I can say my Fc now can also be tension equal what mv squared over r. Meaning this one is in the case of a rope. Please take note in the case of the rope. When you tie a ball at one end of that rope and you wear it around, you know how to wear. You know how to wear round. This I hope you know how to wear. You wear this ball round, you know it's centripetal force that will keep that ball along that part. And the force that will provide that centripetal force is non-tension, and this one can also be used as the formula. Okay, now we are now looking at static now. What can provide this force? What can provide this force when a car turns without sliding? When a car turns in a curved path without sliding? It means that static friction will provide it. Static friction will provide it. Now, what is static friction? Please don't forget, our static friction is Fs. It's Fs. We say static friction can provide it. Therefore, now we can now say static friction is equal Fc, which is centripetal force. Therefore, what is our static friction is mu S, mu S Fn, please don't forget, equal Fc. Please don't forget that. Please don't forget that. In this case now, I can say that my mu S, which is the coefficient of static friction, please don't forget. And what is Fn? Fn is mg. Please take note. Fn is Fn, which is the normal force, is mg. And what is Fc? We have done this one before. We have done this one before. It's something we have done before. Okay, mg. And what is Fc, which is centripetal force? Look at it here. We have done it. Look at it here. We simply bring it here and see mv squared all over r. Therefore, now what can we do? Our m here, we can cancel out this m, and what will be left? We are going to be left with what? Mu s g equal v squared all over r. Okay, now we can make, I can make v here, which is the velocity, the subject of the formula. I make it the subject. What am I going to have? I will have to multiply both sides by arrow. I will multiply it by arrow, I will multiply it by arrow. If I multiply it by arrow, I will have mu s g arrow, and I will also multiply it by arrow, I will be having v squared. Please take note, I will be having what? V squared. Now, to find our v squared, what can we do? We simply find the square root of both sides. Therefore, I will have what? V equal mu s g arrow. This one becomes the formula. As we are looking for the maximum speed of this. Okay, what do they say we should look for? Let us see. Okay, they are asking for maximum speed. Okay, from what we have here, they are asking for maximum speed. Say, what is the maximum speed at which a car can safely make the turn without sliding? Therefore, this one becomes the maximum speed. We are going to use this formula to solve right now. Let me now play the other end of the board as we solve. Let me play here. Let me play here as we solve. Let me play here. Okay, now, using this very one to solve now, what can we do? We want to use this one to solve. What can we have there? From what we have here, what is my mu s? My mu s, okay, my p is equal this very one now. This is the formula. Let me bring it here. Let me bring the formula here. What is it? Mu s. Okay, g arrow. Okay, now what is my mu s? My mu s is given is 0.60. And what we have as our g, please don't forget it's 10. And what is our radius? The radius is 20. 20, and when you multiply now, let us multiply, here become, it's going to be 0.60 times 200, because when you multiply these two, you have 200. Okay, now 0.60 is the same thing as 60 over 100, and multiply 200 now. Multiply 200, what happens? This 0 keeps this 0, this 0 keeps this 0, what left? 60 times 2, and 60 times 2 is simply 120. Therefore, I have the root of 120. Now, you press the root of 120, the square root of 120, you are going to have the root of approximately, I'm going to be having approximately 11 meter per second. We are going to have what? 11 meter per second. Therefore, that one becomes the maximum speed at which this car can simply make the turn without sliding. Can you see now? This is just a simple word solution. This one is just a simple solution to this problem on the board. Thank you very much for joining me on this platform. Thank you for being patient, and God will bless you for this. And you have, okay, we really have a lot to do on this aspect. We really have a lot to do on this aspect. Please just keep the time with me and stay on the platform as we progress in the teaching. Thank you. God bless you.